joking? I'll be serious. Let's see, what did he say?
He was serious.
Baroque, Moving Heartstorm, Fleetwood Mac, Albatross and Burns.
That was the first one.
Vista Social Club.
Yeah.
And then he finishes heck with Almost a Normal Day. So it wasn't quite normal, no. Alright, what's our next topic? Last time we did first principles. I think the next one is derivative by rule. Is that right? What do you mean? Oh, ICT, you have that today. You'll learn a bit about Excel in it.
Is this ICT lesson necessary for the coursework? Or does it have
No, I mean, Joan or whoever is doing ICT is going to show you how to do some useful things in Excel. Of course, you don't. I mean, some people might have different ways or different programs. It's just there to help you. Come on, Omar. When do you have ICT today?
After we have an hour break.
And then you have ICT. Okay. So last time we were looking at first principles here. So now we're going to have a look at derivative by rule. Who remembers what the word derivative means? No. This is an English class. Maths class. Derivative. Noun. What does it mean? Please do not use a different form of the word to explain it. Please.
It's the opposite.
Come on, more than that. No. Yes. Of. Thank goodness. Derivative is slope of the tangent. So, last time we had this method called first principles, but of course this is a very long method. We want a better way to solve problems involving derivatives. So, what we're going to look at is how to find the derivative by using a rule. So, let's say for example you have something like y equals x power n. Derivative by rule. And I would like to know what's the derivative here. So last time we learned, for example, if we had x squared, the derivative is 2x. Yep. So what is it when it's a power like n? What's the general formula? So we'll go about it the same way as last time. We have x, and we have xn, and we have x plus delta x, and then we have x plus delta xn. So the slope of the secant will be x plus delta xn minus xn all over x plus delta x minus x. Okay, doke? Yeah. On the top we have x plus delta xn minus xn all over delta x. So on the top, yeah.
Oh, why did you put the triangle before the y and not the x?
Oh yeah, that's weird. Okay. On the top, what will we need to do? Expand, yeah. Using what we learnt in the lesson with the C, NCR. So this would be NC0 xn delta x0 plus NC1 xn delta x, or n minus 1 delta x1 plus nc2 xn minus 2 delta x squared. Remember this in the sequence lesson? And that continues, and we have a minus xn at the bottom. So what cancels here? Well, have a look at this. What's nc0? 1, so that's gone. What's delta x0? 1. So here you're left with xn. xn minus xn? 0. So this cancels this. And then if you look here, what's in common to all of these that's also on the bottom? Delta x, so we can cancel delta x. So that's gone. This becomes 1, and the next one becomes 2, and so on. So you're left with this. nc1 xn minus 1 plus nc2 xn minus 2 delta x plus nc3 x n minus 3 delta x squared, etc. Now, if I make this a slope of tangent, a derivative, all of these become 0 except for the first one, which is nc1 xn minus 1. Well, what is nc1? Do anyone remember from the triangle? N, yeah. Because if you think about it, you always had this. The first number is always the row number. So, for example, this is this one here, 4c1. This one here would be 3c1. This one here, 2c1. So nc1 is n. So in other words, we finish with this formula. If y equals xn, then that means the derivative is equal to nx n minus 1. Okay, so please write this down. This is our first rule.
What is the difference between tangent and derivative?
Tangent by the word tangent by itself, or something else with the tangent? Derivative is the slope of the tangent. So it's kind of like it's just the m. Whereas tangent, I would take it to be more the mx plus c. Does that make sense?
Okay.
So, in other words, tangent is mx plus c. Derivative is just the m. Yeah. Did you write this down? Yes. Yep. Okay. Are we just waiting for you again?
Okay, you can stop.
This going to the gym is doing nothing for your speed.
Yeah,
Nothing.
It was writing, yes.
They don't have handwriting machines at the gym, no?
No.
Okay, can I scroll down? Can I scroll down? Okay. So, let's have a look at some examples of this rule. So, if y equals x cubed, what does dy dx equal? 3x squared. You bring the power down and you reduce the power by 1. What about if y equals 4x squared? What would you get here? 8x. Now, what about if y equals 6x? 6, because 6x is like 6x power 1. So dy dx will be like 6 times 1 times x power 0, which is just 6. So it's just the 6. What about 6? 0, yeah, because 6 is like 6x 0. So dy dx would be 6, 0, x power minus 1, but that's all gone. It's just a 0. Okay, what about this one now? What should I do here if I have a root x? Yeah, it should be x power a half. So dy dx would be a half x power minus a half, which is 1 over 2 root x. And then one more, y equals 1 over x. What should we change that into? X minus 1. Yeah, so dy dx equals minus 1x. Yeah, which is minus 1 over x squared. And lastly here, actually, what's also nice about this rule is it also works when you add. So for example, if you had 3x squared plus 2x plus 1, the derivative would be 6x plus 2, yeah. Okay, so here's a few examples. You can see they're very short. You should be able to do, okay, maybe not right today, but in the future at least, you should be able to do these quickly. They're supposed to be quick questions to do, okay? So can you write down all of these examples, please? And then I'll give you a harder one to try now. What the heck? Come on, Isa. Got that? Okay, let me give you one to try. Try this one for me. Y equals 1 over root x. I want the derivative.
Could you go back to the question before? I just want to ask.
This one?
Yes.
The proof, yeah?
Yes. Like the part where there are c divided by delta x.
Yeah.
The last part, and then the numerator. Why is it minus x then?
That's this guy here.
Okay.
Do we have answers? We have answers? We have answers? Okay, so what should I do first here? Well, first I should change this into x power minus a half. So the derivative here will be minus a half x power minus 3 over 2, yeah. For a second there I thought you said 3 over 3. Like, no. Yes, well, oh, you're smart. Right, this is minus 1 over 2 square root x cubed, yeah. Okay. Yes.
Like when we change it to a fraction, don't we flip the power 2?
Which step?
The last one.
Here to here?
Yeah.
No, the minus is flipping this upside down, but the power doesn't flip upside down. So you mean like if it's a over b, it should be b over a?
Yeah.
No. Okay, continue.
Yeah.
Right, let's give you a hard one now. I want the derivative of this function. differentiate.
Where does it come from?
Which one?
Like this one? I mean, like which question?
Oh, they're all coming from here right now.
Could you just explain like how did he do it so far?
Do what
The
with that?
X part.
Which part exactly? The last
How
part?
did he get the half first of all?
The half?
Yeah.
Because it's square root.
Okay. And
The
then-
minus because it's underneath.
And then the next one.
Bring the power down,
Okay.
reduce the power by 1, subtract 1 from the power.
Okay.
Then I simply change this back into a fraction form. The negative means it's 1 over. The half makes it a square root, and the 3 makes it a cube. Have an answer? So, it's quite peaceful. We must be missing Faisal. Who else are we missing now? Nader, yes. And Wong is here. Oh yeah, there you are. Yeah. Yusuf. There you are. Does Faisal really make that much noise? It just seems so much quieter. Yeah. Alright. So when you're watching this video later, Faisal, what's up? Okay, do we have answers here? So how to do this one? Anybody figure out how to do it? There is a rule, but I haven't shown you this yet, so you can't use it. Sadly not. I said the derivative only works when you're adding. Sadly, when it's division, you can't do it this way. Yeah. So, what you have to do first is simplify it. We can simplify it by dividing. X minus 1 divided into x cubed plus x squared minus x minus 1. So first we have x squared, x cubed minus x squared. Subtracting, that's 2x squared minus x minus 1, right? Plus 2x. 2x squared, mistake? No, 2x squared minus 2x. Subtracting x minus 1, so that's a 1. So this can be simplified into x squared plus 2x plus 1. And now because I'm adding, I can differentiate. The derivative here is 2x plus 2. Got that? What's the derivative of this one? 2 pi? 0. Why? It is just like a number. There's no x. Always get some people. Just be careful with that one in the exam. Okay. Right, now, some more rules now, because we've just done x power n, but of course there's other functions like sine, cos, log, and so on. So when you're ready now, I'll give you the other rules. I won't prove the other rules. You don't really need a proof on the exam, but You know from the last lesson, first principles method is on the exam, and they usually ask you a power, like x squared or x cubed. So the first proof is just good practice again of first principles. Yep. Okay, can I go down for the other rules now? I'll make a table. So here is y, and here is dy dx. So the first rule we've done, if you have xn, the derivative is nx n minus 1. Next one I'll do is sin x. That becomes cos x. Cos x, that becomes sin x.
Oh, is it
Minus, I was just about to fix it. E nx becomes n e nx. Interestingly, you might think it should be n minus 1, but the n just comes down in the front. So another one that you might often see is ex by itself just becomes ex. Yeah, because the n is 1. Next one is log x. Does anyone know this one actually? Greg? I thought you had it there. 1 over x. Yeah. Almost, yeah. And then I think the only one we haven't done actually is tan x. Anyone know tan x?
1 over the sine.
Yeah, cos squared x. This, I'm pretty sure this is in the formula book. Maybe it's not exactly like this, but you do get a table in the formula book.
They give you formula book.
Yeah.
You're thinking of that.
Yeah. I should have saved that until the day as a surprise. Sorry, said it too soon.
That's like a cultural shock.
Yes. Please write this down carefully. Okay, do you have this table? Great. Let's do another one now using something new. I think I'll do a log one now. Can you try this one, please? Y equals log 4x.
And then this is 0 because there is no power, and this absolute power is 0, so x goes away and it's just 2.
Okay, what answer did you get?
1 over x plus 1 over 4.
Ooh, you were right there for a bit of it. Huh? 4 over x? No.
1 over x.
1 over x, yeah. Why 1 over x? Well, you first must realise we don't have a rule for log kx, log nx. We only have a rule for log x. So we have to simplify this first. By using the first rule of logs, we can say y equals log 4 plus log x. And the derivative of log 4 is 0 because it's a number. And log x? 1 over x. Yep. Okay, let's have a look here. Ugh. Out of memory. I want to give you one more to try here together once it loads. There we go. Okay. I want dy dx. What will you need to do first here before you can get dy dx? Make y the subject. Okay, try this one now. Get the dy dx here. Who's my South Korean students? I'm sorry to hear about your president.
Hated her anyway.
Okay, all right. No problem for you then, huh?
It was the first.
First impeachment, yeah?
Yeah.
Really? Okay. I suppose you have to be famous for something, so. Okay, did you get an answer here? So you have 4y equals minus 3x plus 5. So y equals minus 3 over 4x plus 5 over 4. So what does dy dx equal?
Minus 3 over 4.
Yeah. Now, what about if I changed it slightly? If I said 3x plus 4y equals 5, and I want dx dy.
You put the y over x.
Yeah, well, one way is you just make x the subject. So we get 3x equals minus 4y plus 5. X equals minus 4 over 3 y plus 5 over 3. So dx dy equals... Now look at this answer and look at this answer. Notice anything? It's just flipped. So in other words, it is right to say dy dx, or well, maybe I'll do it the other way, dx dy is just 1 over dy over dx. You've got to be careful. Sometimes in the exam, not often, it's only happened. Question?
So with the log derivation, if it's a log x squared.
With a power. Yeah, let's do another one like that. Yeah, I suppose you could say it, yeah. Sorry, give me an example. Y equals...
Like y equals log e divided by 4.
Like log x4.
Log x4, yes.
Yeah, let's do that one. Okay, can we do another example? Yusuf. Obviously I meant that, Yusuf. Y equals log x4. Do we have a rule for log x4? Well, not really. The 4 is a problem. But we can use one of the rules of logs to change this into... yeah. No. X. So what's the derivative here?
4 times 1 over
4 times 1 over x. Now you might be wondering, is it right to multiply the answer by 4 if the question has a 4 in it? And it is, because if you think about it, you can change this into log x plus log x plus log x plus log x. And what's the derivative here? 1 over x plus 1 over x plus 1 over x, which is 4 times 1 over x. So my point is, numbers that are in the front, you can just put them in the answer. You don't have to worry about them. So for example, if I had y equals 2 sine x, I don't need to worry about the 2, because I know the answer will have a 2 in the front, and sine x becomes cos x then. Okay, please write these down. Okay, you got this? Just before we do the questions, just some notation. This means derivative. But just so you know, this also means derivative. F dash also means derivative. Can we think of anything else? Sometimes what I like to do, and in some books, is separate the dy dx out separate and kind of write it like this. Because if you want to get really technical about it, it's actually this part that means derivative. So this is like derivative of y. This part means derivative of y. This means derivative of f. So that's why often I like, for more difficult problems, to pull this out separately. There is one more. I think they kind of like it in Germany. Derivative. Could have a d, capital. So this is derivative of y, and of course this is like derivative of f. You could also write the f dx. Could go for some kind of fancy d and fancy f. These are all the different ways to write or to mean derivative of y function, x function.
So what's the difference between y and x?
Nothing really. Like, you could say y equals x squared plus x plus 1, or you could say f of x equals x squared plus x plus 1. There is a technical difference, but for the moment I'm happy just to tell people to think of y and f of x as the same thing. Okay, can you note these different ways of writing it? Because maybe some of them you haven't seen before. Yeah? Yeah. Okay. So, homework, which you can do for a couple of minutes here. all of question 1. And then, so, question 1, all. Question 2, A to I. Yeah. You don't have to do number 3 or 4. So, just 1 and 2.